Hello? 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 Hi, everyone. We're going to start very soon. Probably in like 1 minute. Cool, amazing. Hi, everyone. Welcome to HackDuke Code for Good 2025. We're really excited to welcome all of you here to Fuqua School of Business, where we're going to be hosting the event this year. And we think we've kind of spent a lot of time working on putting effort into organizing this all for you, and we hope you all will really enjoy it. So I'm just going to take you in this presentation through a little bit the logistics for the event, things that you should know. A lot of it maybe you already read in the Hacker Guide. It's good to go over these things again so that we're clear on them. And then we'll also have some addresses from some sponsors that are important to us, and then also from our speaker. So firstly, just on talking a little bit about HackDuke. So these are the two of us, the two co-directors for this year. So I'm Rally. I'm a sophomore. I go to Duke. And Kevin, who is not here right now, he's also a sophomore. He goes to Duke. So a little bit about kind of HackDuke and what we are. So HackDuke started, I think, a long time ago in 2013. It started as HackBlue, which it was for 1 year only, and then it changed to HackDuke, which was probably, I think, the better choice. This year, in fact, it's been going on for a really, really long time. We did it all throughout COVID, and we've had kind of up and down years. This year, HackDuke was, if you might not already know, it almost didn't happen because we had a lot of leadership graduating. I guess a lot of people and experience was leaving the organization, but we had a lot of new faces come in and really wanted to put on the hackathon and make something like this possible. And we're really happy that we were able to kind of put in the effort throughout the last 6 months to be able to bring this to you. So a little bit about you guys. So right now we have 400 hackers from kind of all different kinds of places. Of course, a lot of you are from Duke, but we also have a lot of faces from other places as well. We have people from UNC, NC State, all over the place. We have people from pretty far away who came a long way to come here and compete with you guys. And so we're really excited to be hosting so many people. I think this has been the first time ever that HackDuke has had so many people from different places, not just Duke, competing. And we're really excited that I think in the future, we're hoping that this can grow to be not just like a North Carolina Research Triangle kind of area event, but also to more schools as well, and to expand to bringing more people to Duke and to experience, I think, what a lot of us think is a fun and learning experience. So let's talk a little bit about the quick details of the hackathon. So hackathon, as you probably already know from signing up, but if you don't, it's essentially just a certain time period which you have to build a project to present it in a very fast-paced environment. And so you can experiment and work on a lot of different things. In our case, our hackathon is 24 hours of hacking. So it starts actually 11 a.m. I think we pushed that back to 11:30 a.m. Saturday, which is in 30 minutes. And it ends 24 hours later, so 11:30 a.m. on Sunday. For teams that you can build things in, the team cap is 4. You can do however much lower than that. So if you want to have 1 person on your team and work alone, that's fine. If you want to have up to 4, that's fine as well. If you don't have a team already, I'm going to go over a little bit later the processes that we have for you to be able to find a team and to be able to meet others who you want to work with. In terms of what you can build, so you can actually build whatever you want. Don't be misled by thinking that the tracks are the only thing you can build for. The tracks are just how we give out our prizes, but we also have like a best overall prize, which could go to anything, even if it's not necessarily within one of our tracks. You can see all of our prizes in the hacker guide. I'll go over a few of them a little bit later. And all activities will take place here. So at Fuqua, you don't necessarily have to hack here, but I will say, a lot of our things will be here. Our food will all come here. So you want to get food. If you want to get merch drops, I think we're going to do like raffles for a lot of merch that we got from our sponsors. Then I think that will be here as well. Please keep this space clean. Fuqua has, I think, spent a lot of effort into cleaning up this space for us, into setting it up for us, and we want to leave it the way that we found it. So please don't leave kind of trash everywhere. Clean up after yourselves. I think Fuqua is really nice as a building because, in my life, I don't think I've seen any buildings or rooms with that many trash cans. So you should be able, I think, to throw away all of the things that you need to, and hopefully we don't have kind of the overflowing garbage problem, which, occasionally happens at Duke University events. Cool. Let's talk about our tracks. So we have 4 tracks. We have sustainability, health, finance, and interactive media. We've written kind of short descriptions for that. You can interpret these tracks however you want. And in our cases, we're going to be giving out prizes. So we're going to give out a grand prize and a runner-up prize for each one of these tracks, alongside a couple of other miscellaneous prizes as well. So those are our tracks. I want to talk a little bit about hardware because this is something that's sort of niche. Usually people don't build that much with hardware, but we do get, of course, a few teams every year that are interested in doing hardware things. So we do have hardware available for you to borrow. We have things like Raspberry Pis. We have Jetson Nanos that you can borrow. We will have a hardware desk right now set up. It's like on the right side of Kirby Winter Garden. If you go in through check-in, it's on the right. For expensive hardware, we do ask that we'll exchange like the hardware with you, and then you'll give us your ID, and we'll hold on to that for 24 hours until you give us that hardware back, just to ensure that that's returned, because it's really expensive. The full list of hardware is available in the hacker guide, and we'll also organize a trip to the Collab, which is one of our sponsors this year as well, and you'll be able to use a lot of the equipment there that isn't available at Fuqua. So for example, if you need to solder something, you can do that in the Collab. If you need a 3D printer and you need to print something, the Collab is available for that as well. For our schedule, I won't go through every single element right now. You can find this yourself. Right now, we're at the opening ceremony. Hacking is going to commence, and then after this, we're going to have a few team formation things. But the most up-to-date version of the schedule, and this is probably important to note, will always be available in the hacker guide. So if you look on our website probably won't have the most up-to-date version of the schedule at all times, but you should know that the hacker guide is what you should follow, and that's the schedule that's going to be there. We also printed out a few copies of this. It might be outdated by the time that you end up reading it. So really, the hacker guide is your best resource. If you don't have access to that link, I'm going to put up a QR code in a little bit, but your teammates should have access because we sent that through your email multiple times. We also have a couple of talks. So we have Kyle, who is our opening ceremony speaker right here. We have Jacob, who is our closing ceremony speaker. And then we have a few workshops that are being led by a variety of different companies and also Duke organizations that are going to be available throughout the day. And they're all on our schedule for you to participate in. You can learn some things from there. They can help you with any projects that you want to work on during the hackathon. So those are things that are available for you as well. In terms of hacking spaces, so we do not have access to McClendon Dining Hall, which is the big dining hall that you see basically everything left of that big wooden wall separating the two spaces. So we have Kirby Winter Garden, which is like the big space with all the tables, with all of our banners, with all of our decorations. We don't have access to that dining hall. They're having Fuqua Blue Devil Days during that time. So we won't have access to that for basically the most of today, I would say. And then if overnight some people want to work there, that's probably fine. But we don't have access to that space. What we do have access to is, firstly, we have access to Kirby Winter Garden, which is that space that I was just talking about. You can work at any of those tables. We have lots of tables set up. We have lots of tables kind of around the outskirts that you can also work at. And we also have this space as well, Janine Auditorium, that you can work in. I will say for this, we're going to be very strict on there being no food being allowed inside this or any of the other auditoriums, because we need to keep these spaces clean. And with a lot of people and a lot of food, it just ends up making a big mess. So if you want to eat, you can eat in Kirby Winter Garden, but just don't bring your food and trash and that kind of stuff all into here. And yeah, this is just reiterating that McClendon Dining Room is off limits, so please don't sit there. And then, like, you know, there will be a big hassle because there will be people from Blue Devil Day there as well. Okay, for sleeping, in case you guys are planning to sleep here, which a fair number of people always do overnight, we do have a place that's available for sleeping. So Jenkins Classroom, which is at the very back of Kirby Winter Garden, is opened at 11 p.m. We're going to set that up. We'll have a limited number of sleeping mats. You have to bring your own, I think, as we already said, sleeping bag and things like that. We don't have showers in Fuqua. If you need to shower, you should probably talk to a Duke student. We can let you into some places where you'll be able to shower or show you where you might be able to shower on campus. Okay. For judging, so to be eligible for judging, you need to submit on DevPost and also have your project on GitHub. Like to submit on DevPost, you need to have your project on GitHub. So if you don't know how to learn use GitHub, plenty of us are going to be available around. We have mentors to teach you how to use GitHub. That's something that you should probably familiarize yourself with, because that's how you're going to be doing that submission. And then you'll submit on this platform called DevPost. One thing that we will be checking for is if your GitHub repository has commits from before hacking began, like from 3 days ago or whatever, that will disqualify you from receiving any prizes, because this is supposed to be a 24-hour hackathon that you're supposed to work on during the time that is allotted. So that's something that we're going to check for. And so just be careful about that. In terms of how the actual judging will happen, so every project that submits to DevPost will be given a table in Fuqua Atrium. We're going to set that up. And then judges will come around. They'll score your project on Gavel, which is this software that lets you kind of rank projects. And then we'll receive and release decisions at the closing ceremony. In terms of our prizes, I mean, this is just a look at some of the prizes that we have available for you. We have lots of other prizes too. So as I already mentioned, we have grand prizes. We have a best overall prize. We have runner-ups. We also have a best beginner hack, which is for beginner teams, which I think is teams that have 50% or more beginners, or it's their first hackathon, as you indicated on the form that we sent out to you. And then we also have a best hardware hack, which is the best hack that uses hardware. So which is why I mentioned all the hardware stuff earlier. Lastly, I just want to do some plugging of our social events. So our team has put together a bunch of fun social events for you guys to participate in throughout the entire day today. And so some of them, we have the first two, we have running. So this is just going to be like a running tour of Duke that Lisa will take you on. I'm not sure if she's here right now, but you guys will meet in the Fuqua Atrium and go on a running tour of Duke if you're interested in that. We have poker night, which is going to be tonight from 7 to 9 in Jenkins conference room. That will be organized by Catherine, who's over there. So if you have any questions, ask her about it, and then some other people as well that you'll see mingling around. We also have game night, which is going to be, we'll have board games that we have available. And then we also have Nintendo Switches that you can play on in one of the auditoriums over there. So that will be in Sauer Classroom from 7 to 9. And lastly, we have Stargazing, which is going to be 11 to 12 at here, but we're going to walk you to the Duke Gardens, and then we'll be able to do that. So if you look in Kirby Winter Garden, we have these posters set up with all of these social events. So if you need a refresher on the details, you should go and take a look at those. Great. Okay, last two things. Just join the Discord and view the hacker guide if you haven't already. If you have any questions, you can always feel free to reach out to us over Discord. So that's a great way to reach out to us. If you need to know who is an organizer to get help from, we'll always have organizers on duty, like 24 hours. So all times there will be some organizers on duty. We're gonna have we have these like vertical badges. So judges have horizontal badges. We have vertical ones like this. And then we also have these blue lanyards. And we should all be wearing sweaters or like crew necks that look like this. And they have a big HackDuke at the back. Great. And thank you so much to all of our sponsors, without which any of this would not be possible. We really appreciate all of the help and support in any way that all of our sponsors give us. And this really wouldn't be possible without all of their help. Okay, cool. I want to invite now Duke I&E to talk a little bit about what they do.
Hey, good morning, everyone. How's everybody doing today? Good, good. Awesome. Well, just wanted to thank you all for coming out. Lots of amazing energy in the room. HackDuke, thank you for the opportunity for allowing us to be a part of this event. So just want to tell you a little bit about myself and Duke I&E. So we understand that entrepreneurship can be very challenging, confusing, and it can be difficult to find your people. So we're here to help. Some of the things that we provide our student community, not restricted to students, alumni as well, but some of the things we provide are money, know-how, and community. And a couple of ways we do that, one of our upcoming opportunities is the Startup Showcase. So last year, in this very room, we gave away over $110,000 in non-dilutive prizes. And that was for student founders, essentially where you all are this morning in Kirby Winter Garden. We had tabling for students who had ventures. And we also had a kind of like a Shark Tank type of event. So if that's something that you all are interested in, please feel free to reach out to me. There's also a QR code there. We also have Quad Cup Pitch. So for the Duke students, this is an opportunity for you all to work together with someone in your quad, develop a team, work on pitching something for a grand prize of a trip to New York City, get to attend a Knicks game. And this is a collaboration with our team as well as Student Affairs. So here's the QR code for that if this is something you all are interested in. And then we also have our mentors in residence. So essentially, these are two founders who have started and scaled businesses and have great experience. And they're excellent thought partners, for instance, if you have an idea and you want to go from ideation to a prototype. Or if you need a thought partner or any sort of resource, we pay them a retainer to have office hours calls for students with questions. So I won't take any more of your time, but thank you for the opportunity. You all will see me throughout the weekend. Feel free to come up to me, reach out to me. Thank you.
Okay, now MLH will come and talk to us a little bit.
Okay. Hi, everyone. While we're working to kind of fix the issue with the slides, I'll introduce myself. My name is Lavi. I'm from Major League Hacking. Can I get a raise of hands if you have heard of MLH before? Okay, awesome. So I'll keep this introduction brief. I assume most of you have done a hackathon before or you have heard of MLH before. Oh, thank you. So my name is Lavi. I'm a coach here at Major League Hacking. I use she, her pronouns, and this is my first time at Duke University. I'm a senior at USC in Southern California. So being this far on the East Coast is kind of throwing me off, but I'm really excited to be here. Everything you need to know in terms of MLH prizes this weekend can be found at this link, but it'll also be posted in the Discord as well as on the dev post. And we also have a global Discord that you can connect with other hackers worldwide if you go to discord.gg/MLH. So after this weekend is over, that doesn't mean the hacking has to end there. You can feel free to join our own hackathons that we organize, which are virtual and accessible for everybody. If you haven't heard of Major League Hacking before, we're a global hacker community comprised of over 1 million hackers just like yourselves globally. So we host events in Asia, in the European region, as well as in the United States and Canada. This weekend at HackDuke, we have a couple of mini events and workshops coming up. So right after opening ceremony, concurrently with team formation, I know a lot of you might have come in without a team or might not have known someone, especially since you're coming in from so many different schools. So I'm hosting a Tech Together meetup, which is an initiative by MLH to kind of bring underrepresented genders into technology. So feel free to come by. We have special stickers as well as scrunchies for all of our attendees. And this is right after opening ceremony, so you can follow me right after this. I'm also hosting a workshop in partnership with GitHub Copilot, which is kind of like a pair programmer that can help you debug as well as write code. If you want to grab the student developer pack right now, I recommend going to mlh.link/pack. And the way that this works is you give your EDU email, so I assume most of you it's duke.edu, and they'll verify that you're a student and give you some free perks. So in this case, they'll give you free use of GitHub Copilot Pro, but you can also get free tools. I think in the past they've given like 6 months of Canva Pro, or you can get like different AI tools as well. This will be from 2 to 3 p.m. today, and you can sign up here at the link. So I know that was pretty quick, but I'm also going to go over some prizes. Like I was mentioning, AI is pretty big. So we have best use of Gen AI, and I'll do a quick demo of what this can look like. So can you all see my VS Code? Okay, perfect. So in this demo, I'll be quickly covering how you can build a project with Gen AI. But in the project category, if you're submitting a prize, your app has to use Gen AI towards like the end user, so like a chatbot or something. But in this case, I have a Gemini API key, as well as these Klein rules. So what we're going to do is we're going to copy this prompt. So I'm saying you want to follow best practices, use the Gemini key that I'm giving you, use Tailwind for styling, but not compiling it locally and using the CDN instead. Using ngrok to make the web app available to other computers, not just locally. And basically making a single page Python Flask web app that has a chat interface. So basically a really simple chat bot. So like I said, we'll copy this prompt and we'll paste it into the chatbot here. And it'll basically create an API request. Like I said, we're using Gemini here, but you can use any tool that you want, like OpenAI, Perplexity, etc. And I've run this demo before, so I'm kind of auto-approving all of the commands it's recommending. But obviously, if you're doing this on your own, I recommend reading through its recommendations first.
No, from beginner.
So it's like fetching all of the information from the API that it's pulling from. It's running the commands for me. Like I said, I'm giving it auto-approve just to make this a little bit faster. I don't want to take up any of your time. So as you see here, it created an app.python file for me from scratch using the Gemini API key that I gave it. It's also like building the entire app for me like I asked it to. And you can see here that Klein is creating a new file called app.py. It's creating the index.html file. And it's basically going to create this entire website for me, which I don't recommend you do for the hackathon project. But this is basically a really quick cursory overview of everything that you can do with Gen AI. So now it says here that it's running locally. Oh, where did it go? Let's see. Let's see if we can open it. So we're going to go here. Let's see if we can open this. So there you go. You have a Gemini chatbot. So just to make sure this works, we're going to say, hello world. I'm going to send it a message. And then we can ask it, what is HackDuke? HackDuke. And it'll take a little bit to load, but there you go. So it's fully formatted. It's not the prettiest website, but it's pretty functional. And it has a correct sort of definition and overview of what HackDuke is. So that's one of our prize categories this weekend is the best use of Gen AI. Like I said, I used Gemini for the tool that I used, but this isn't limited to just Gemini. You can use OpenAI, Perplexity. I know Arise is one of the sponsors this weekend, so feel free to use that as well. We have the best use of Streamlit, which is a Python library. And you can go to mlh.link/Streamlit to redeem your get started guide. We also have the best use of Midnight if you're interested in like security, data privacy, or blockchain. We also have free domain name codes this weekend. So if you use the code MLHDUK25, you can get a free domain name this weekend. And you can go to www.tech.study to redeem that domain name. And the way that this prize category works is basically you just redeem the domain name. You don't have to like host it or anything like that. I know that was pretty quick. So if you need to see those again, they'll be posted on the dev post and the Discord. And if you show off your hack on, if you show off your hack on Sunday afternoon and show it off to the judges, we also have custom MLH stickers to show off that you demoed your project. And then finally, on a more serious note, hackathons are a safe space for everyone. So don't feel afraid to come by and ask for questions, ask for help, and also do the same with others. So if you see someone struggling, don't be afraid to ask if they need help and make sure that it is an inclusive space for everyone. All right, thanks so much, and I'll pass it off to the next speaker.
It's all good.
That's when I moved to college.
Beautiful. All right. Thank you so much. And then lastly, I want to invite Kyle to come up and talk to us.
Thanks, everyone. So what I want to do today is introduce you to an area of computer science that most undergraduate curriculums don't cover. So this is one of these little secrets that those of us who have been out in industry for a while find out about after the fact. It's kind of this extra little set of information and knowledge that helps you in your day-to-day work that kind of builds on top of the basics that you have picked up during your undergraduate or even graduate curriculum. And that's the idea of patterns. So let's start with what the idea of a pattern is. A pattern is a named, repeatable solution to a problem in a context. Now, the problem with that definition is it's so concise, it's absolutely meaningless. But let me give you a little bit more about what this means. It's a way of connecting specific issues that we as developers or we as humans run into constantly, time after time after time, and then providing us with a common solution that others have found to be useful for solving that problem, but doing so in a structured way using prose and diagrams. It's the best way that I have found in the 30 plus years I've been in the industry for us to take that kind of undocumented, hidden knowledge that senior devs, senior architects have, and then convey them to the people that actually need to use them, which is you folks. So where did this idea come from? Well, the idea of patterns came to computer science from a really unusual place. It was from built world architecture. Now I have to distinguish built world architecture from software architecture because they're two different things. By built world architecture, I mean like building buildings, putting things like this building together. Architecture has a set of common practices It has a set of vocabulary that architects speak that is completely different from the vocabulary that we use when we're describing software systems that we're building. That is a problem when you're talking from an architect to a client. Because guess what? It's just as hard as an architect to talk to a client as it is for a software engineer to talk to someone that you're trying to build a program for. That's because there's this vocabulary gap that you have to be able to bridge. Well, looking at that vocabulary gap, there was someone at University of California, Berkeley, named Christopher Alexander, who had this idea of how to bridge this gap. And he thought what you could do is you could bring together these two groups of people, the clients and the people that wanted to build buildings and live in buildings, together with the architects that could design buildings. And he documented that idea in a series of books, starting with a pattern language in 1977, and then going on to A Timeless Way of Building in 1979, and another one called The Oregon Experiment that I think came out, if I'm remembering it right, in 1981. But the idea was to, for him, state a solution as a name, state the problem and the forces, the tension in that problem, what made that problem hard, and then show how those forces are resolved by the solution. What is it about this particular solution that makes it feel good when you actually see the solution to the problem? Okay? And then finally, his last insight was you want to show how that pattern fits together with other patterns. Now, what did Alexander actually mean when he meant this? Well, let me take a pattern from this room. Where are the doors in this room? Can everyone point to them? Actually, you missed one. There's one over there too. Notice where the doors are in this auditorium. It's the corners. Now, this is an odd-shaped room, so it's only approximately the corner, but it's the corner. Now, what would happen if the main door to the auditorium was right here? It would be a nightmare if anyone was trying to set up here on the stage, trying to, set up some tech or a demonstration or anything like this, because people would be walking through it. Likewise, if I put the door right in the middle of that wall over there, you would have people coming in and going up and people coming in and going down at the same time, and it would be a nightmare trying to deal with this. In other words, putting things in the middle of walls is bad. Putting doors on the corners, though, that seems to work. And what Alexander said is when you do that, when you put corner doors, you create a space, this space here in the middle, that he says is untouched by movement. Because naturally what will happen is people will move along the edge of the walls to find their seats. That's a simple built world pattern. There's another one that you've probably got an example of. Think about your favorite room where you like to do most of your studying, where you like to do, let's say things that are enjoyable like playing games and things like that. Think about how it's oriented. Do you like rooms that are all dark? Well, some people do, but not many people. Most of them like well-lighted rooms, especially if you're trying to read or you're trying to, talk with friends or do anything like that. Do you want light just on one side, like this? No. People tend to gravitate to corners. They want light on two sides coming in toward them. And if I think about my house, if I'm thinking about my favorite room, my wife's favorite room, my son's favorite room, guess what? They're all the corners of the house. That's because this idea of light on two sides is really, really attractive to us as humans in the way that we like to live out in our spaces. That's a pattern. It even connects to corner doors Because if you don't want to screw up having the light on one side, you don't want to put the door in the middle of it. You want to put it over on the corner. See how this kind of works? Well, where did this then connect to computer science? For about a decade, maybe more than a decade, like 15 years, this was like this weird fringe idea out in architecture. There were, 4 books written on it, maybe a couple dozen papers, a little bit of a buzz in the architectural community, but it generally got subsumed into this kind of broader architectural set of discussions called habitability, and it kind of disappeared. That is until someone else discovered the idea. And that someone else is a remarkable person in computer science. His name is Ward Cunningham. Ward invented something that you've probably all used. How many of you have ever used Wikipedia? Oh, come on, the rest of you are all lying. We've all used Wikipedia. But you know how it's built? With this idea that you've got the hyperlinks directly into it, and if you click on a new hyperlink that doesn't exist yet, you'll see it in a different form, and then you'll be able to then go into editing mode and fill in that hyperlink. That idea of a wiki web was invented by Ward Cunningham, and then it was only picked up by Jimmy Wales about 2 years later, when Jimmy was looking at one of Ward's sites and realized this would be a great way to build a crowdsourced encyclopedia. All right? Ward thought of that idea because he was thinking about how patterns connect to each other. He had read a pattern language, and he had this wacky idea. He was thinking, when I'm thinking about user interfaces in computers, that seems a lot like building rooms. And he got together with another one of his buddies, a guy named Kent Beck, who will re-enter the story later because Kent Beck turned to have been the guy who invented, agile development. And together they came up with a couple of simple patterns. One of the easiest was verbs go in menus. Think about every menu you've ever seen. Hey, that's right, verbs go in menus. Well, where do nouns go? Nouns go in lists. That's pretty much true. And they took a bunch of simple patterns like this and came out with a pattern language for describing user interfaces, which they then submitted to the OOPS conference. Well, where that then came together is a lot of other people saw that paper, and they then started reading Alexander's book. And they started thinking about the things that Alexander had said about this idea of problems connecting to the core of the solution and how that describes something that you see over and over again. And they started thinking about other places besides user interface design that this basic idea might occur. Like, for instance, maybe not just built world architecture, but what about software architecture? And in fact, that then led to the next part of the story, which is a number of kind of friends of Ward, which is probably the way to put it, and that includes a bunch of the early luminaries in the object-oriented design community, like Grady Booch, all got together at Grady's instigation, and they went out to Grady's house in Colorado, and they said, can we do something with this patterns idea? Out of that came a nonprofit called the Hillside Group. The Hillside Group was named that because literally they all went out on a hillside outside Grady's house and decided to try to use Alexander's patterns to see what it would be like to design a conference facility. And guess what? It worked. They were able to kind of figure out how to put this all together. And since that was enough proof to kind of prove there was something of an idea there, they decided to start a nonprofit and a conference out of that, the Pattern Languages of Programs Conference, which then started in 1994. Well, this is where I finally get involved. Turns out I was working for one of those folks that was invited to that first meeting, Ken Auer, at a little company here in Cary called Knowledge Systems Corporation. And Ken got in contact with all these people who had attended this, and we started looking at early versions of a lot of these papers. In fact, one of the sets of papers that I started getting, that we all started doing a little reading group around, was a set of papers from 4 academics, 2 of them from IBM, and then 1 from the University of Illinois, and 1 from, I think at this point it was from ETH in Zurich. That was a set of papers that turned into a book called Design Patterns, Elements of Reusable Object-Oriented Software. That book changed my life. Because every so often, you come across a book that seems to speak to you, and you never know why, and you never know how it's going to happen. But that book managed to do that for me. See, as I was reading through that book the first time I got a hold of it, and I actually did this on a long car ride to Atlanta from here one day, where my wife was driving for 6 hours and I just had time to read. What I realized is that I had seen all of these individual ideas in software engineering, in building software architectures that the authors of this book had come up with. And I was able to then explain to others, oh yeah, I've seen this in this particular situation. Like for instance, let me just give you one of them. There was this pattern that they have in here called interpreter. What's an interpreter? Well, here's the idea. How many of you have ever looked at a compiler, taken compilers? Okay, that's a, somewhere in between advanced undergrad, early grad school course. I'd say half of you have probably seen it. Compilers have the following idea. You take a structured language and you build what's called a parse tree. Okay? Parse trees are really simple. It basically says you end up having a data structure, a node, for every piece in a language. So let's think about a really simple one. 2 plus 2. 2 plus 2 means you've got 2 nodes on either side representing the numbers 2 and 2. And then you've got a node in the middle representing plus. That's how you parse out 2 plus 2. Well, as your equations get more and more complicated, that just becomes a deeper and deeper tree structure. Turns out, data structure-wise, you can represent that really simply with basically just 3 data structures. You need something representing your terminal nodes, the 2s, and something representing the non-terminal nodes, which are the pluses and the minuses and the equals and everything else that's inside of it, okay? And then that allows you to build up these tree structures. Well, here's the thing that was totally mind-blowing when I saw this, because none of this had come out of my compilers class. Once you've built up that abstract tree structure, once you have your abstract syntax tree, you can evaluate the whole thing from top to bottom in one method. All you have to do is a tree traversal. You can basically say each of these individual nodes has a different method, a different function attached to it based on the type of thing it is. If it's a number, if it's a math operator, if it's any of these different things, you just attach a different method to it. And then you just evaluate the thing in a top-down traversal. So essentially it starts all the way at the bottom and it says, what's the value of that? 2. What's the value of the little thing on the left? 2. What does this thing do? It's a plus. Oh, well that means I take the 2 things on either end and I add them together and then I return 4. And you do that on the next level up and you do that on the next level up. And this completely blew my mind because in my compilers class, I was thinking, well, then you've got like 15 extra steps you have to do to evaluate your language. You've got to build an intermediate representation. You've got to take the intermediate representation and you've got to compile it. You've got to optimize it and you've got to yada. No, you can stop right there. And that turns out to be the core of a really important idea that then developed out of that. And that was this idea of what are called domain-specific languages. That's the idea that if it's this simple to build an interpreter, you can build them for really small things that happen all the time in the problems you're running across in day-to-day life. All right? Keep that in mind, because that will come back in a few minutes. Well, what it turns out happened to me next, because again, this is a combination of my life with patterns, so it's not going to be all patterns, is that wonderful time I was having at that little company in Cary didn't last that long. I took that job basically so I could have a job while I was attending grad school at NC State. I spent 7 wonderful years there, and then something happened in 1997. You see, what happened was Sun released this computer language called Java. Well, this entire company had been based around a competing computer language called Smalltalk. And what happened in 1998 was, because Java became so popular so quickly, the entire company, and in fact the entire industry, collapsed in about 3 months. And I found myself looking for a job, which is very common in our industry. And I somehow ended up at IBM because I had learned enough about patterns and learned enough about Java at this point that when IBM was starting a new product group around Java and they needed someone to be able to teach that product to their customers, I had the right skills to be able to apply to that. And in fact, I had already published 1 book at this time, which really helped in my resume. That book was what I had done on all my work in Smalltalk around patterns, called the Design Pattern Smalltalk Companion. That idea is something that I then repeated time and time and time again over the next several years at IBM, is that I would essentially work on something with a customer, I would look for the patterns in that thing, and I would write a little article around that pattern. Then I would take that article, combine it with 2 or 3 other articles around other patterns, and then I would submit a conference paper. I'd build up 5 or 6 conference papers, and then I would approach a publisher and say, hey, I've got this idea for a book that's this combination of 5 or 6 conference papers. And almost every time they fell for it. As a result, during this time that I was with the WebSphere group at IBM, I published 5 more books, all through this idea of never publishing anything once. Now, the thing is the patterns that I was finding turned out to be related to this basic idea of just looking for the issues that I'm having when I'm talking with my customers and finding that kind of issues in communication, issues in vocabulary that we're running across. Let me tell you about one of them. This one was kind of fun. One of the customers that I had as I was working with this was the US Federal Reserve. In fact, it was the Federal Reserve Bank of Richmond. And one of the issues that we were dealing with was in building the payment system for pretty much the United States. The way in which this works is this. Have you ever noticed that when you submit a payment, you use Apple Pay or use a credit card or anything else, it doesn't automatically, immediately come off your bank account? You notice there's a little bit of a lag there. Why is there a little bit of a lag? Well, it turns out that's because it's not synchronous. We all know synchronous communication, right? That's the way all of our computer languages work. Well, it turns out there's this whole other world called asynchronous communication. And asynchronous communication really comes in whenever you have enormous volumes, like trying to handle all the payments in the United States all at once. Well, the problem that we were dealing with was we simply wanted the ability to match up one asynchronous request with the eventual reply that would come back asynchronously at some undetermined point in the future. Turns out that was moderately challenging. especially when you're talking about billions of requests going one way, sitting for some, undeterminate amount of time between seconds, milliseconds to hours, and then trying to figure out which one matches on the other end. Well, it turns out there was a really easy solution to that, and that was called a correlation ID. A correlation ID is simply where you say, I'm going to generate one really, really long UUID, and I'm going to attach it to every message that goes onto my request queue. Then when I'm looking for the reply back, all I have to do is I just have to search through all the ones and find the one that has the matching number on it. That's not that hard. But it turns out this is what was needed to actually make the payment systems work correctly. And this is another one of these examples of a problem that would have been hard to explain to someone who didn't have the vocabulary. But once I explained the idea of a correlation ID, all of the accountants suddenly understood it. And they were able to kind of then figure out exactly how this system was going to function, whereas previously they could not follow any of the explanations we were trying to give them. Well, that notion of just looking for those little patterns, gathering them together over time, eventually figuring out ways to publish them in larger and larger groups seemed to work out for me over time. And that actually helped me to kind of slowly climb the ranks at IBM to become what was called a senior technical staff member, which is, a senior engineer, and then a distinguished engineer, which is their executive version of the same thing. So I'm at the second highest level that you can be as a senior techie within the corporate world at this point. Now it's 2014, and I'm starting to get, honestly, a little bored because I've been doing roughly the same thing now for about 15 years. And I start looking for something else. Well, at this point, this is when I managed to get together with another one of my friends who was also looking to do something different. And we start looking at what's happening in the technology world at the time to see where we can have an impact. And we were able to, at this point, do something that in the outside world would have been called being an entrepreneur. But since we managed to figure out a way to do it within a corporation, was called being an intrapreneur. We started what we called the IBM Garage. The IBM Garage was meant to be a consulting group inside IBM that was working with and embedded in all of the hacker spaces and all of the co-working spaces that were then cropping up all over the world around 2014, 2015. Okay, this worked out amazingly well because it turns out that if you want to introduce technology from a company that maybe a lot of people aren't familiar with, a great way to do that is to sit with them. And so that's what we did. We ended up founding, if I can say the word founding, founding garages in innovation centers and tech hubs in San Francisco, in Austin, in London, in Singapore, we had them in Sydney, Australia. We had them in a whole bunch of other places, Munich, you name it, that gave IBM a whole new set of customers by allowing us to have a different way of interacting with a whole new set of styles of people that we were working with. Because IBM at this point was very well known to big clients, but not so much to startups. So we did that. We were amazingly successful. We started up, I think, 22 of these garages within 2 years. We brought in, at this point, about $50 million of revenue into IBM Cloud, which was the unit that was sponsoring us. And that led to well, no good deed remains unpunished. Me being asked to work with one of these big clients. And that big client was American Airlines. American Airlines at the time was being asked to adopt all of these ideas that the startups were adopting. And so they came to us at the garage in San Francisco and said, this is great. We're not a startup. Can you guys do the same thing with us? And our response was, yes. While our response after they left was, we have no idea how we're going to make this do. We're going to have to figure this out on our own. And so that led to me having to invent a way of taking the magic that we had been doing with these startups, all of the design thinking exercises, all of the agile development practices, things like extreme programming and test-driven development and automation and all of these things, and then making that into a formal method that could be used by a company the size of American Airlines. And it turns out we were successful at that. And American Airlines became one of IBM Cloud's top clients. That, again, led to me then being named what's called an IBM Fellow, which is the highest technical rank that we have within IBM. I'm, at this point, essentially a vice president. And then, just when we were having the most fun with all of this, COVID happened. And every single one of those tech hubs and those co-working spaces that we were working in, all closed. And again, I find myself, just like I had in 1998, in a market that has completely collapsed. And even though I'm inside IBM, I'm basically without a job inside IBM as a brand new IBM fellow. Thank you very much, IBM. But I then managed to connect to something else, and that was joining the IBM CIO office. Because the IBM CIO office had a slightly different problem that we had been running into over the years. See, here's the issue. One of the patterns that we had been promoting through the garage and the garage method, which IBM itself had adopted internally a lot, was this idea of microservices. Microservices is the simple concept that if you're trying to build a big distributed system, you basically have three different boundaries. You've got your code module boundary, right? We all know what a code module is. But who works on a code module? You don't build it as an individual usually. Code modules are too big for that. You have to build a code module as a team, right? And that's a unit of delivery that you're going to actually then deliver to a customer. Well, the problem is that's not the only boundary you have. You have not only the compilation boundary or the delivery boundary, you have your team boundary. Who's going to be responsible for that, and how many code modules is that team building, and do they ever cut a code module in half on a team boundary? Well, if that ever happens, you have two teams working in the same code, that's a recipe for conflict, and that's going to immediately give you some issues. The final question then is a distribution boundary. Well, a distribution boundary is then, how are these going to connect to themselves over the cloud? Guess what? If those don't match your team boundaries, then you're going to get into arguments over what the API is going to be and how that's going to be handled. That has resulted in an idea that we call microservices, which is set the three boundaries to be the same. Every module is delivered by a single team and has a single consistent API that's owned by that team. That is fantastic, except for one problem. This makes it easy for you to build very, very quickly and to keep your teams out of each other's way at the cost of there being, within a single large application, possibly up to 100 or more of these microservices, each of which have their own individual CI/CD pipelines. take that 100 CI/CD pipelines and multiply it by the 1,000 applications that we have in the IBM CIO office. And now you start to see the problem. We have 100,000 separate pipelines that we were trying to manage and deal with, and it had become probably the most complicated problem we had in the CIO at the time. So what was the answer to this? Well, we took a step back and we started thinking about all these different pipelines we were building for all these different microservices, and we realized something. It's like, wait a minute, 90% of these are all the same. We do the same thing. We build an application in Java, or we build an application in Python or Go. That part looks the same. We run it through a bunch of scanning tools for different security scans. That part looks the same. We do a bunch of unit tests on it. Okay, once we're in a specific language, that part looks the same. The only difference is the output that you're getting from each of these. That started to sound an awful lot like a domain-specific language to where we were able to describe, here's the individual statements in that language. This is just a config file, by the way. We just did this in YAML. And then build an interpreter to actually go through this and call the appropriate nodes to build all of this at once and then run this through. At this point, we were using Jenkins. Turned out that solved our problem by just going all the way back to the interpreter pattern and bringing it forward into this idea. Well, was that enough? Well, that kind of got me started in my new job as the Chief Technical Officer of the IBM CIO office. But again, that led to the next problem that we're having. Now that we've been able to get our teams to be more productive and spend less time on just the mechanics of delivering their applications, we were then asked to take all that extra productivity we had just discovered and use it on something that the company could get some value out of, which is, can you guys take all of our brand new AI products and become the showcase for all these new AI products? Well, that led me to the next set of patterns, the final set of patterns that we've kind of discovered out of this. First one is RAG, Retrieval Augmented Generation. Okay, I'm going to go back to our previous speaker and I'm going to point something out. Remember when she asked remember when she asked Claude, I think. Couldn't remember if it was Gemini or Claude. She asked Claude about HackDuke. How many students did Claude say were participating in HackDuke? 1,000? How many students did our previous speaker say are participating this year in HackDuke?
400.
Oh. So you're telling me that Claude made that up? What's that called? A hallucination. That happens all the freaking time when you're dealing with large language models. In fact, you can't escape it because it's built into the temperature parameter. If you want a large language model to basically give you human-sounding things, you have to set the temperature parameter above 0, which is then going to absolutely guarantee you will always have hallucinations. Well, that sucks. What are we going to do about that? Well, it turns out there's a solution to this. The solution is LLMs are really, really good at summarizing things. If you give them a stack of real, trustworthy information and tell it to summarize it, the result that you get back is usually way more accurate. And I'm talking a difference of about roughly 60% accuracy to high 90s accuracy. That's the basic idea of what's called retrieval augmented generation. What you do is you take a whole bunch of trustworthy information You run it through a data pipeline, and then you run it through half of an LLM. Why only half? Well, remember how LLMs work? They've basically sucked in the entire internet, and as they suck in the internet, they basically play a game of Mad Libs. They try to figure out what the next most statistically reasonable thing is in a sentence. What that's actually doing in the LLM model is it's building up a deep learning network that has a set of weights on it. Every time it sees a new word in the training set, it's adjusting those weights. But that's happening at thousands, millions, billions, in fact, of places within the LLM. In other words, what it's saying is each particular piece of information is encoded by the position of where that particular concept has been strengthened and arrives inside the LLM's data set. That's a position in a vector space. If you imagine every individual parameter as forming a point, essentially what we're doing is we're defining a vector through, some enormously large vector space to where that piece of information is. Well, you can combine that with another idea, which is the way that that works is all of those related pieces of information are going to be stored together. They're going to be close in vector space. You can then compute a cosine similarity between any two pieces of information, and you can find where they're located. Once we've done that, that allows us to stick that into what's called a vector database and then pull it all out so that it can be summarized, moving your accuracy all the way to the top from somewhere in the middle. Now, there's one more basic idea that we want to throw at you, and that is this idea of the reasoning and action pattern. React basically asks me very quickly, I've got 2 minutes, It asks you to basically let the LLM come up with a plan and then execute the plan by calling an API. Cool. So if I did a lookup to find out where my information is, and then I ask it to execute on my plan, I can actually see that I can go from learning to doing. Pull those two things together with a router in the middle, and you've just defined essentially what is an agentic architecture for LLMs that is going to have high accuracy and high reliability through what you're doing. Now, the last thing that I want to show you is a last problem that ties back to the previous speaker. The little demo that we just saw running, which was fantastic, by the way, illustrates both a problem and a solution at the same time. And I want to point out the problem and the solution. The problem is when you're dealing with different types of information, representing it as a text flow to where you have an entry field and a response field is not necessarily the best way to represent your information. It is the most common way to represent interactions with an LLM. I will totally agree. But this idea of a big separate chat window is not going to be either the most attractive or the most useful way of interacting with an LLM. But did you see what the previous speaker did in her demo? She asked the LLM to generate a web page. What if you were able to do that not just for a simple chat interface, the big separate chat window, which by the way is an anti-pattern in many cases, but instead generate a more useful interface that followed a different set of patterns, like present me tabular information as a spreadsheet, or present me graphical information as a pie chart or a bar chart or a line chart. That idea of letting the LLM dream the interface is where we are now. I've seen this implemented a couple of times, but I think this is the future of where we are now going with user interfaces. So think about this as you're looking at the problems that you all are solving. By the way you specify this, to tie it back to the first one, build a domain-specific language, build an interpreter for the domain-specific language, and have all of the individual pieces pull it all together like this. And with that, we're done. And I think we've talked about all these pieces. You've seen how this has not only given me architectural guidance, but career guidance at the same time. All right? Thanks, everyone.
Hi, everyone. So we have lunch right now. We have Chick-fil-A sandwiches. It's available over there. So you should go and get in line. We also have, I think our sponsor fair is going to be very soon. And we have right now going on just, it's going to be like a little mixer for people to meet each other. And then we also have the Tech Together thing by MLH. That's going to be in Sauer. So you can get your food and then go. I think that would probably work.
Yeah, we started. Yes.